problems. We are going to make our own equations, but once we have an equation, we know how to solve this now. But this is the tricky part, is how do we make our equation? Okay, so this says you sell tickets for a concert $9 and 200 people come. For every $2 increase in that ticket, then 10 fewer people are going to come to your concert. So what we're trying to do is figure out the price to sell those tickets at, because we want to get our max revenue out of the situation. Okay, so revenue equals, in words, how would you figure out the revenue of doing a concert?
Ticket sales.
Ticket sales times the price. So ticket price, I'm going to write first, times, can I replace ticket sales with just the people? The number of people? Does that make sense? We're going to take that, whatever the ticket price is, and times it by however many people or sales are happening. Okay, so give yourself two brackets. The one bracket is going to represent what's going on with our ticket price, and the other bracket will represent what's going on with our people. Okay, let's talk about how we started. So the ticket price at the start was $9 a ticket. And the people at the start, that means there's 200 people coming. Okay, so what was happening to our ticket price? It said for every $2 increase, 10 fewer people are going to come. But this is missing something. How do I know I'm just increasing $2? What if I want to increase $2 and maybe another $2 and another $2? I don't know. What should I do in math with something? I need a variable. Pretend this went up $4. Then this better also go down more. The same. Yeah. So if you do this jump twice, the people have to go down 10 and 10. Okay, so does that make sense how to start? Okay. You know how to go from here. You know all the math stuff. So what would be the next math maneuver if you saw something that looked like this? Just generic math maneuver. Simplify it. What's the specific thing that simplifies this? I heard it over there. Foil it. Simplify it, so that means I'd have to foil this out. Tinfoil it out, yeah. Okay, 1800 is first. Out would be subtract 90x. In is plus 400x. Last is minus 20x squared. Okay, on the test I feel like, actually that's the spot where people make the most mistakes. It's the foiling. So go slow, make sure you get all the parts. We can put those together. Okay, and there's my quadratic equation.
Are you going to have to do this on the test?
This is for sure on your test, yep. Do you guys like the way it looks, or do you want me to just move it around? Because often when we've been looking at them, we do our A, our B, and our C, right? We go in order. So You can leave it like that. That's fine. If you are a person that has to see stuff differently, you can do the minus 20x squared first. But sometimes people somehow lose their negative sign if they're moving stuff, so don't do that. Do you see your components? Your ax squared plus bx plus c. Okay, so I'm in general form. Ax squared plus bx plus c. How do we get the max? So this is revenue, so I'm making money, and then I'm eventually going to make more money, and then I'm going to start losing money. How do I get the max? What's that special point called?
The vertex.
The vertex. How do you get the vertex in this form?
Negative a over.
Negative b over 2a. Okay.
Negative 2.
This is on your formula sheet. This little tiny formula is on your formula sheet, but I don't say it together. I don't say use this when this. I don't say that, but I have this on the formula sheet somewhere and this on the formula sheet somewhere. Okay. No. If you look on your original formula sheet that I gave you on day 1, that would be kind of what I give you. I'm not even sure, but
That would have opposite and same.
like that, kind of. I don't say HK, I don't say negative B over 2A plug-in. Okay, negative B over 2A. So, negative 310. We're okay with that spot? Negative 310, because that's the B, over 2 times negative 20. And when I'm typing this into my calculator, what should I make sure I'm being very careful with? Brackets. Okay, 7.75, everyone was good with that number because they did their brackets. So that's the x of the vertex, and if I plug it in, I get the y. So if I were to plug that in, what is the y in words? What is it actually doing? What would it find if I plugged it in? It would find the revenue. Do I care about the revenue? No. I don't need to know the revenue. So, this is the question. What price should you sell your ticket?
$7.75.
Not quite. What did we do to represent the ticket price? This whole thing represents the ticket price. And do I now know what the X number is? That's now the X number that I want.
Like a lot of money, bud. No, look at it. You have to put that right too. That's nice. I was gonna have your
Okay, so on that question, once you get that X value, understand where to plug it in. So if I do say, what's the highest revenue you're going to make, where are you going to put that X value into? You're going to put it into revenue. Revenue equals negative 20 times 7.75 squared. Okay, But if I ask for ticket price, you're going to plug it into this bracket. What if I asked you how many people are going to show up? You're going to go 200 subtract 10 times 7.75. Okay? So watch what I'm asking for, because you're going to have to say, where do I plug it in at the end? Okay, number 2. You have 240 meters of fence and divide a rectangular pen into 3 areas. So think about having cows, horses, and pigs, separate pens like that. Okay, what we're going to start with is we're going to put some L's and W's on this to represent lengths and widths. So from that corner to that corner is a length, which is also the same on the bottom, right? And this would be a width. So those are the lengths and the widths of this fence. All of the fence is 240. So I'm going to take that and write it in math. All of those sides of fence make 240. So if I have 2L plus 4W, does that make sense to you? All of the fence added together. That's what I would do. Okay. So that's what we know. Now we're going to try to start maximizing the area. That's our question. So let's talk about area of a rectangle. What is the area formula for a rectangle? Length times width. You just times the sides of a rectangle. Okay? I'm not going to have that on your formula sheet, so that's something from common past that I expect you to know. The length times the width is the area. Okay. If I continue in this isn't going to work. The reason is because it's got 3 different letters, right? When we do quadratic equations, we always have 1 letter there, and then on this side, we need a different letter. So only 2 letters ever, an X and a Y. So what I'm going to do is I'm going to work to get something alone and use it as a replacement. Which letter looks easier to get alone? The L letter or the W letter here? The L, yep. So here's what I'm going to do. I'm going to move that term away. Okay. I get this mistake sometimes. All of a sudden somebody's giving me 236W on that side. Does that work? No, because I can't smush those together, right? I can't put them together at all. They're separate things. You can't ever put them together. Okay, I need something else before L is alone. Divide by 2, which means everything. Everything. So there's another mistake I often see is that people divide this and this by 2, but not that one. You can't do that. You have to do it to everything. So L equals 120 minus 2W. So that's good. We have something alone. So we're going to take this statement here. Does this make sense in math? I'm going to now go over there and replace the L. Is that legit in math? Can I do that? If something is equivalent, I can make a replacement. Does that make sense? Okay, do you see what I did? I made my replacement for an L. Do you see that I put it in brackets?
Yes, I see that.
That's important. If I didn't, it would only be timesing these without that. I don't want that. So brackets are important. Now is where we do the simplification stuff. And all this is old math stuff now. Simplify means, I need to do that, right? Kind of a FOIL, but not quite with the 4 terms.
Because it's W to W raised W.
There's a W in that and then a W in that. Yeah. Okay. Are we okay to understand it looks like this form? Okay. It's just that there's no C, which means C is 0, right? Okay. C is 0, yeah. Which letter is 120 in that? Is it it's the B part? And -2 is an A number. So if I match it to there's no C, so it's 0. Yeah. It's that, but there's just no third part. Okay, so we're trying to maximize something. What do we do when we're trying to maximize something? Vertex. How do we find the vertex? -b over 2a. So -120 and I got 30. Okay, so 30 is the x part. Oh, but it's not x. I don't even have an x. So instead of x, it's what letter? So 30 meters is the W. That's the width of this rectangle. That's what I know now. Okay, what does the question ask? Does it ask me for the area? No. The question says what dimensions? Okay, so at this point we normally plug it in. If we did plug it in, it would tell me what information. If I plugged it in here, it would tell me the area. So I don't really care about the area, so I'm not going to do that plug-in. I'm going to now need to know the length. What is the length of this rectangle? So what do you want to do here? We could go over to this line. Or some of you might understand just how to figure it out with mental math. If those lengths are now all 30. Okay, so length equals 120 minus 2 times the W, which is now I know, 30. So there's the length of the field. So did anybody just throw it onto here with mental math? So 30 makes 120, right? How many meters do you have left now from 120 after 240? If you used up 120, you still have 120 left, but you got to split it, making 60 and 60. Okay, we've done these already, but I just want to remind you. So when you're doing a problem where I've actually given you the equation, you're just analyzing it. You get that vertex, negative e over 2a, plug in. You get that vertex, but you need to understand what's happening. So a y-intercept would represent where you're starting from, the height of something at the start. When you get to that vertex, it's telling you when are we reaching max height, comma, what is the max height? And then the x-intercept here is telling us when does it hit the ground. Okay, we're going to do one in your booklet together, so get into the booklet. Page 9, number 4. Page 9, number 4. Okay, number 4. We have two positive numbers that have a sum of 13. That's what your first sentence says. So two positive numbers, we need to represent those two numbers with letters because we don't know those numbers. So what do you want to use? X and Y. So two positive numbers, so we're saying we're using an X and a Y to be two numbers. What does the word sum mean in math? Add. So two numbers add to 13. Okay, so I converted the language to a math. The next sentence talks about another sum. So the sum means I'm adding their squares. So I'm adding the squares to be a minimum. Okay, so I just took all the words and now we wrote them. Okay, which example is this very similar to? Would it be like the people price example, or would it be like the area example that I gave you? It's like one of them. Area, because I'm dealing with too many letters. So if it's like the area problem, I have to get something alone to substitute it in. Which letter do you want to get alone here? And that actually doesn't matter. X equals 13 minus y. So I'm going to take that and make it a replacement. Okay, so this is the same as the area. I got something alone, and then I took it into the other equation, and I'm going to replace it. Okay, this is a very, very, very important math rule. We talked about it before. When you're squaring a binomial, is it okay for me to just square each term? No, I have to square the unit, which causes a what? A FOIL. Okay, so that's a very common math mistake, is just squaring each thing, but don't forget it's squaring that unit. Okay, 13 times 13, anybody know that one? 169. First times first. Outside makes negative 13y. Inside, negative 13y. And plus y squared. Don't forget, there's another also. Okay, there's my FOIL, and then don't forget we had another y squared. Okay, we can put those together. That's okay, they're like each other. We can put those together. Those are like each other. Are you also okay if I doing ABC in order. Okay, so the minimum equals 2y squared. I'm just rearranging the order because I like ABC. But so there's the 2y squared. How many y's? Negative 26.
Oh.
Those two together, yeah.
Took me a minute.
Okay, I'm trying to find a minimum, which is which kind of point on a graph? A minimum is a vertex. How do you find a vertex? Like this. Opposite of B over 2A. So plus 26 over 2 times A.
I literally am working a different muscle. I can't.
6.5 is what? What is it representing?
Wait, but how did you get X?
How did I get where? What?
The minimum. Y. I thought it was just Y. Yeah, I'll go square. Isn't that true? There's two of them. Oh, what? Where did we get two of them?
This and this together. If you had like a foot squared and another foot squared, you would now have 2 feet squared. So this is representing the y. So what is the other number in this situation? Because our numbers have to add to 13. So the other number is going to have to also be 6.5.